So now we want to find the limit of at infinity. So like for here, limit at infinity, like limit of x tends to infinity. This symbol is the infinity symbol uh, of this function x square. So limit tends to, so this is the infinity symbol. So limit tends to infinity means something is getting larger, infinity, like the highest number that we can have. So that's a symbol showing the number is very, very large, much larger. So for instance, at x tends to infinity, so we can start with, we can just pick a large number and see when x maybe is 100, then the limit of x tends to infinity of x square will be so this x square will be 100 square and it will be 10,000. If x is equal to, for instance, since we want x to be very large, if x is approaches 10,000, then this x square, our function will approach, x square will approaches that is will approaches something. I think this is sorry, will approaches 10 million. So if x is if we put input at x as maybe 100,000, then x square will approaches something like this. So x square will approaches almost 10 billion. So we can see at x become larger, x square become much larger. So that's why we say this one will also tends to infinity, because we want x to be the largest number that we can find, then the x squares will also be a very large number. So this will also tends to infinity. So another example is here the limits of as x tends to infinity of 1 over x. So if you look at this here, we can also try and put some large numbers. Let maybe x to be 10. Maybe, yeah, let's start with not much larger. Then 1 over x will tends to 0.1. If you make it x larger, maybe 10,000, then 1 over x will tends to 0.0001. So you can see x is 1 over x is kind of tending to 0. When x is much larger, it's tending to, that's is tending to infinity, is maybe 1 million. Then 1 over x will be 0.000001. So you can see 1 over x is kind of tending to 0. It's becoming very close to 0 because this is approximately equal to 0. So that's why we say the limit at x tends to infinity of 1 over x is equal to 0, because we are dividing 1 by a very large number. So it's kind of becoming 0. So another example is this. The limits as x tends to minus infinity of minus x cubed plus 2x plus 3. So whenever you have a limit like this, since this is a s cube, so you can easily approximate this limit by your highest power when you have a polynomial like this, because s cube is like it's much larger than this. This is just as an example. Let's give an example. If you have 10 cube, this is maybe, let's say you have a 10 cube, this is this, but this is 1000, but it have 2x here if you have s cube. But if you look at the second time, 2x, it is just 2 times 10 if you substitute 10, and this is just 20. So you can see this one is much larger, and the more you increase this, the more it will be larger. Like if you are s cube, you replace your x with maybe 100 cube, this will be almost I think almost 1 million, but your 2x will just be 2 times 100, which is equal to 200. So you can see this much larger. So that's why this x cube will easily dominate the whole thing. So you can just approximate this as lim x tends to minus infinity. This is just the same as at minus s cube. So you can just pick the highest power And from this one, if you substitute this, so this will just be minus of infinity minus infinity cube. And minus infinity cube is just minus infinity times minus infinity times minus infinity. So infinity times infinity will just be infinity. So you're just like this. When you have 100, this is kind of tending to infinity. If it is minus this, this will be minus 1 million. So it's just tending to infinity. So this is just minus infinity. And this minus minus, so you'll have plus infinity.